Just kidding. All right, so, well, sorry the other hour or second hour, but you got to see this glorious instruction, even though you were complaining about it. A dog has what? Four legs and what? So get over it, that -4 comma, you go to 210, but you don't go 4 this way, you go 4 in the opposite direction. What do I do, -210? So you're actually here for -4 comma 210. Get over it. That's how this graphs. That's what you do. Just do it. All right, and then how about this? Let's go blue. -2 comma negative. Oh, I don't know. Let's just say 60. Well, where's -60 degrees, first of all? What quadrant? 4, so -60 is 300, same as that. So this is nothing new. What's new is, what do I do at -3 or -60? I don't go 2 this way, I go what? 2 in the opposite direction, which is there. Okay, so I don't have time for this, to do these. Notice it says plot each point, which I already did, number 1. But then identify 3 other ways the point can be written in this polar form. So I'm going to go over it so fast, your head will be spinning. 2 comma 30. 2 comma 30 right there. By the way, I would probably want to do this. I just like that. And then knowing where my 45s are. So this is 135, and then I know everything else is 1 away. 1, 2, 3. No, you don't have this one yet either. It's the next page that I kind of try to want to speed things up. 315. Okay, and then 45 is right. Okay, so 2 comma 30. Well, from my other ways of doing this, it's 2 comma what? No time. -330. That is chapter 2, right? Right? Yes, Mr. Samuelis. Now it gets weird. -2 comma. Well, that is 210 over here. So how that would graph is I would go to 210, but then I'd go not 2, I'd go -2. So that's spot on. Now that I have that other way of doing it, it's also -2 comma, chapter 2. -150. It's over. Good night, Irene. Forget about it. Where's -4 comma 2 pi over 3 land? Well, 2 pi over 3, again, I would do this, even though it's not an x and a y axis. I'm just trying to identify the 90, 180, 273, 60 cleanly. And then 2 pi over 3 is the same as what? 120. And that was 2 marks right here. And it is, oh, where does it go, though? Does it go here, or where does it go? Opposite direction. Boom shaka-lockers. So the other way to name this is just to change the angle, knowing your chapter 2. What's a quadrantal? What's the angle that's a negative? I have no time for this. You should have already answered, even though I can't answer the question or even ask it. I don't know what's happening. All right, and then okay, now what's this point the regular way? Well, it's 4 comma. What's this stinking angle measure in a positive manner? 5 pi over 3. And then what's the chapter 2? What's 5 pi over 3 the same thing as? Negative pi over 3. Don't just change it to degrees, whoever just said that. It's not a different answer. Why is he so mean? Oh, I'm just a jerk today. Okay, so now, what you're going to do first has nothing to do with your homework. I just thought I'd want to cover these. I remember doing this back in the day. These were the first graphs that we talked about with the students. Okay. So how does this graph? What? R equals 3? Okay, a silent student number, whatever you are in group 1. Oh, I missed the numbers individually. What the? What are you missing in this first example? Now you have this on your thing. You're missing theta. So what happens when I plug in 0 for theta? What do I get for R? 3. What happens when I plug in pi over 2 for theta? What do I get for R? What happens when I plug in pi? What kind of picture is this going to be? A circle. Whatever angle measure I pick, I'm going to get a radius of 3 all the way around. I want to make sure I don't care what angle. This is going to be a simple circle. Wow. I even have something to trace. Let's move on. Okay, because of time. And because, well, you're going to get, what the heck? I don't know what's happening with my computer. Okay, theta. I hope this is taping. Thank the maker, if there is one. What happens if I plug in 0 for theta? What do I get for R? Okay, mark it, dude. All right, by the way, I would do this. 90, 270, 180, 0. And then I'd mark 45s. Let's do radians. Just to pi over 4, 1, 2, 3, 3 pi over 4. And then just know the 60s are close. And then 5 pi over 4. And then this is 7 pi over 4. 1, 2, 3. Okay, don't make a big deal. The test is Friday. You can complain all you want. You better figure it out fast. He's so mean. Pi over 6 for... Now, give me that as a decimal. This took 7 minutes for second hour to give me the decimal. I have no time for this. What's pi over 6? 0.5. So what I want to know is, I want to know what that is as a radius value. So at pi over 6, I go only out like 0.5 something. That's going to be strange. And then let's go like pi over 4. You better give me as a decimal so fast, my head will be spinning. What? 0.78. Who do we appreciate? All right, not Mr. S. Not Mr. He's a jerk. Okay. 0.79. It's fine. All right, so we made a little boo-boo there. What's pi over 3? 1 point. Well, let's actually find it. 1.05. So this is strange. Pi over 3, get 1.05. If I connect these right now, this is what I'm getting. Anyone have an idea what this is going to be a picture of? Delicious. A spiral. What's pi over 2? 1.57. Thanks for your help. All right, so pi over 2, 1.57. And then let's skip all the way to pi to just get this over. What's pi? It's a 3.14. What is happening? 1, 2, 3.14. So as these angles go bigger, this spirals out. And then it just keeps going and going and going. You know what's strange about this? I didn't get to cover the second hour because I knew we were way running out of time. This is the only one of the few graphs that this weird thing happens. What happens when I start going negative, which I've been doing all day? Get it? All right. Does this map right on top of this graph? No, it doesn't. Because here's negative pi over 6, right? Right, which is 11 pi over 6. But how am I supposed to graph it? I'm supposed to go the opposite direction. So what happens when we start incorporating negative angle measures and positive angle measures? You actually get two spirals. What has happened? Why is my... I don't know what... This is... Okay. Oh, you get this spiral that goes this way, well, and negative angle measures in. There is a problem. My computer has never done this before, right? So that we can infinity, this spiral is going to infinitely go out all the way. So very straight. Incorporate Van de Pop. End up spirals. You can investigate that with your if we talk about these on the calculator. Now, okay, I apologize a little. Should have had these filled in, and this should have had filled in. Or number, what is 1 theta? Help me. Who has one of those? This is what? Okay, so what you decide, this over in the regular plane, in the polar plane. What we did a long time is we analyzed these values here, and it was kind of an issue. But all it takes is of elbow. Oh, man, there is something going on with my computer right now. Major. Oh boy, that's what is happening. Okay, so this out so computer-wise. Okay, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Here's 2 pi. 1, 2, 3. Center space pi. Pi over 2. In second hour, hopefully you're watching this, because we are going to have a test Friday. I'm going to test you. Going to get you. All right, and then this is, we have new, we go from 1 to 0. I'm sorry, 2 to 0 as our high and lows. So let's say this is 2, and this is 1. And then this is 0, because this graph gets moved up 1, right? Because the graph and also the chart of values, and put them both together to get the polar coordinate graph. And then we have a regular sign, so we start at 1, and that corresponds to that. This is the high point. This is back to the middle, low, and then back to here. So that's what I meant about, fine, fill out the chart. Do you see these little flashing things? I'm going to have to restart my computer after this hour. All right, and then we go to the coordinate plane for this one. I don't know if we'll have time to answer these rich, cool questions. I like marking 90, 180, 270, 360. And I also like marking the 45s because I know 1, 2, 3. So go ahead and do that along with me. 1, 2, 3. Yeah, this is weird. I have a major issue going on. So hopefully this survives. I'm actually nervous about the video too because of this. All right. So how do I graph 1, 0? Well, 0 radians is this. And I go 1 out. So that's how we start. There's 1, 0. Got it? Must move on. Pi over 6, comma, 1.5. Here's pi over 6. Here's 1.5. Nailed it. Here's pi over 4, 1.7. That's approximately here. And you feel free to go ahead of me. Pi over 3, comma, 1.9, which is very close to 2. And then, lo and behold, pi over 2, comma, 2. So really what we have right now is this. And we can connect those dots because there's more angles than that. And I missed some of the dots. I apologize. But all the other angles in between, you can be assured there's a little curve connecting those. Then when we proceed on, 2 pi over 3 is back to that 1.9. Then 1.7. And then 1.5. And then pi ends up being 1. So here we go. We got kind of like, what does that look like? Not quite circular, but kind of, right? Yes, Mr. Thamulith. All right, and then 7 pi over 6, which is right chaw. You end up getting 0.5, right? Is that right? I'm trying to look at two places. Nobody's talking. There is a class in here. Holy crap. 5 pi over 4, comma, 0.3. This is weird. Okay, it did go in there. And then 4 pi over 3, comma, 0.1. And then, lo and behold, 3 pi over 2, comma, 0 goes right there. So when I graph this, this actually does this. And then when I take those other points, you get these points over here. I want to make sure I get this right and not do this too fast. Hey, what does that look like, everybody? Well, someone said an apple in the other hour. Now, you know what happens if you keep going? Well, what happens when you keep going on this chart? What do these values do after 2 pi? They repeat. Guess what happens when you do this graph? It repeats and covers itself. So there's your picture. You just accomplished a polar graph. No time for questions. Let's move on. Now I went ahead and snapped the graph here because, and actually I didn't even get to do this with the other hour. And there is an issue. The chart is not always sufficient. You're going to have to figure out from the graph as well what the coordinates are for the polar situation. Okay? So take a minute to snap that graph down. I'm going to press pause. Okay. Maybe I'll be fine now. I closed some files. We'll see. I like marking the x and the y-axis, and I do have some critical values here. Okay, so we're going to go super fast on this. Oh, by the way, again, you know, where do you get this picture? You're going to get it in the homework tonight. I'm going to put all 1 through 9 on the homework. Then you can look at the picture and a chart of values and then go to your snapshot it, the best ones, and then put them online. And then you can use the pictures plus charts to fill out these. So let's go ahead from this picture. Well, this is strange. We're already at 0, -2. So where does that mean I go? Opposite direction. There's our first point. Now, here's where it gets a little crazy. And you might want to look at the chart of values. You know, maybe you could help me on the chart of values for this. What was the next one? Okay, this is what I need. Who has, what number is this, by the way? What number is this? This is where it kind of went bad with the other hour. What's 1 minus 3 cosine theta? 4, right? Okay, so who has 4? I need coincide here. You have 3 different groups. Pi over 6, comma what? What'd you get for pi over 6, comma? -1.6. That means you go 1.6 this way. The opposite direction of 1.6. Okay, what about pi over 4? What'd you get for that? Now we're moving. -1 point what? 1.2. Then what did I get for pi over 3? -0.5. Okay, those all work. Then what do you get for pi over 2, which I do have right here? What do you get for pi over 2? 1. So this doesn't just skip to here. Now what we want to do is look at what happens in between pi over 3, which what kind of r did we get? It starts with an n, negative, and then pi over 2. What kind of r did we get for that? Positive. So at some point, one of these angles, whatever it is, does give me 0 for a radius. So that point does exist, and we have to kind of look at the picture for that. And then what happens after that? I don't know. It gets a little bit small. So these angle measures right here give me like little small angle radii value right here. So you can be assured that there is a little picture right there. Do you see that? Do you understand it? And then we do get 0, 0 because one of these angle measures does give me 0 for an r. Okay, so that's what we have to do with the graph. We have to fill in some missing parts because the chart is not always going to hit everything. So you have to use the chart and or the graph to understand what happens on this polar coordinate plane. Now let's continue. What time is it? Ah! Okay. I might have to do the last one like, during 7th hour if you want to see what happens with the last one because it is very strange. So we'll finish this one off good. I'll finish this video, maybe post it, and then later on I'll do the last one and you can see that at 3 o'clock. And we'll go real fast with it. Okay, so now what happens after this? Now I need your help. What's 2 pi over 3 comma? Negative again? Are you sure? 2 pi over, no, because 2 pi over 3 between, I should be getting positives. It's what? 1.5, so you got to be careful. And then what's 3 pi over 4 give you? Is it 3.12? Is that right? That doesn't seem right. Is that right? Is the first one right? 2 pi over 3 comma 1.5. Is that right? Okay, this is what... We got it. Okay, what's 3 pi over 4 comma? 3.12? Now we're moving. What's 5 pi over 6 comma? 3.59? This is 3.59. So it's not hard, but it is tedious. That's a difference. Problem is the youth of today don't want to do, put all the elbow grease in and then they complain about it. Is that you? No, good head shake. All right, then what's the last one? Pi comma 4. Okay, so when we finish this off, this is what we got. All right, and actually, as the bell is probably going to be ringing in minutes here, what we're going to get is the completion of this with a little hole in here. All right, which almost looks like the last one, but we have a little hole in the middle of it. Very strange, because that's what we've accomplished so far, this part of the graph. So this part of the graph is going to give me a mirror image of this. It's symmetric. Okay, so because of time, I'm going to go over that one real fast. What was this, 3.59? You should have got 3.59 for that one, whatever it was. Whatever this one is, that's what this one should be for 3.4. Whatever this one is, that should be this one. And that's what your chart should say, and it should coincide. And then, whatever this one is, what's weird is that's what that one is. And that's what that one is. And you can coincide this with the chart. 1, 2, 3. 1, 2, 3. I'm just kind of trying to make this go fast, which sometimes speed what? Anyone? Hurts sometimes. Okay, so you can verify with the chart that this is what happens with these values. Okay? Very strange picture, isn't it? Very odd. Okay, so all you have to do is put elbow grease into looking at the graphs and or the charts, but then graphing them on a polar coordinate plane, which does get a little crazy. Tedious, careful, figure it out. Okay? And like I said, on a separate movie, I'll do this last one. I think we started it in 2nd hour, and it didn't finish, and what I needed to cover is the chart doesn't quite do it. You do have to look at the picture to fill in some missing parts, and I'll do that online later. Pause. Okay. I forgot I wanted to start off by showing you that this is how you want to do your homework, which I've already posted on the calendar, various student work. I actually stuck with just 2nd hour's work. It was good enough. Actually, I apologize, 2nd hour. 4th hour fumbled the ball even more than you did on filling out these charts. No offense, 4th hour. I gave you an easier task. But anyway, enough of the ribbon on people. Good afternoon. But what I found out when we were going through this one in 2nd hour, we actually have to look at more than the chart. It's also the graph, and we have to fill in some holes. I mean, there were some major holes when we were going over the picture. We only got through 0 to pi, But then, I got to readjust how we think this. So here is the last example. And actually be helpful to have the picture here. And then I'm going to start from scratch because just looking at the chart itself wasn't good enough in order to get a real decent picture for this. So like I asked, I think this is how we started. We started by saying, sorry, I don't know why that just popped up, but when I plug in 0 for theta, I end up getting 0 for the output value, and this is going to be kind of tough toggling back and forth here. So 0, 0, boom. And then I asked, and you did tell, what's pi over 6? And we got pi over 6 comma 3, 1, 2, 3, so we did have that. Then when I asked, what else did they have on this chart? 45, 2.21, and then 60 was 0. So 60 was back to 0. Pi over 4 was 2.21. So that's somewhere in here. And I kind of circumvented the graph real fast. I said 4th hour. Get the chart, but also just do your graphing like we know how to do. Get your 4 critical values, but then also refer to the chart to see what are these values in here. And then we have to even go further than that because what we missed was all these values. So that's why I'm going to go back. So pi over 4 we saw on the chart was 2.2, I think. And if I'm a little bit off, that's fine. But what happened here? And what happened here was anything before pi over 6, all of these angle measures, gave me all these radii values from 0 all the way up to 3. So these angle measures, this real small angle measure close to 0 radians, gives me a radius value very close to 0. Oh, for the love of dog. And then all the way up to pi over 6, the angle that's really close to pi over 6 gives me a radius value very close to 3. So actually, we have a mirror image like over here. Some angle measure gives me this. So we missed this little part of this from this part of the graph analyzing that. So again, my chart isn't good enough. What you should be looking at is also the sketch on these pieces of paper and fill in some holes that might exist. And that should actually be okay. We really shouldn't be having a hissy fit over that, if I can, express that way. All right, maybe not, but that's fine. All right, so pi over 4 is right here. Pi over 4 gave me 2.2 approximately. That's that on the graph. Let me erase my scribbling here. Well, then what about all of these angle measures and all of these radii values? That's covered by, this right here. Because then when we went to pi over 3 gave me 0 again. So we had to fill in those holes with the picture, not the chart. Boy, I've said that like a million times. So we're going to get a sketch out of that, and that's how we have to really kind of think about this. And then we got to take this chunk right here. What in the blazes happens here? Well, the next one after pi over 3, what's pi over 3 again? Oh, that's 60, right. So then we went 90. That's pi over 2. Oh boy, I'm struggling on where I'm. Pi over 2, and that gave me -1. So pi over 2, which is this angle measure, actually gave me -1, which I don't know why I'm going farther. I'm sorry, wait. I'm screwing up already. -1 times 3, which is -3. I knew I had a problem with that. -3 on the chart. What's going on here? And what you missed is, maybe all these critical values right here. So anything right after pi over 3, which is all of these angle measures from here to here, those give me all of these negative radii values, which flashes across over here. All right? And then up to pi over 2, which gives me this negative. So what's this one? This is a very small, so very close to pi over 3, which is like right here, flashed across. All right? And then very small. And then all the way up to here, very close to pi over 2, is very close to -3. So very close to pi over 2, very close to... So what you get is this little thing, very exactly the same as like these little arcs that we're getting right here in these pictures. Uh-oh, something wrong with my computer. Then we go past pi over 2, we get these same values here. So a little bit past pi over 2, we're very close to -3, which flashes to the other side. All the way up to, this is getting all cattywampus here, Where was the next 0? 180, is that pi? I'm all messed up here. So pi over 3, pi over the, oh gosh. Let me pause this for a second. I've jacked up my graph. I can't even find a pause. Yeah, it was 2 pi over 3. So sorry about that. I just trying to get this going here. So 2 pi over 3, which is 120, is back to 0. So what happens between that? So all I want to do is locate that from here to here. These are the special angle measures that create flashing across this other part of what is really what's called a rose. Isn't it pretty? Well, we'll find out in a minute. Then I'll explain that one more time better than how I started. Just past pi over 2, we get a negative close to 3, which flashes across to here, which is where then very close to 2 pi over 3 is very close to negative number that's very close to 0. Now these other ones flash across and give all these points right here, negative radii that flash across over to the other side. Okay? So then 2 pi over 0, I'm sorry, pi over 2 to 2 pi over 3 gives me this part of that rose. All right, so you just got to do a little bit here. I'm not asking much. All you're doing is analyzing these values as output values, but then putting them on this coordinate plane over here. All right, now what's after 2 pi over 3? And I probably should mark these up so we know what they are on this thing. So 2 pi over 3, 4 pi over 3. Let me mark these up a little bit better so they match the chart a little bit, and then I'll come back. Okay, so I had to go back to over 6s. So this is 5 pi over 6. What I want to identify are the next chunks that get me, the next critical little part of the rows possibly. This is 6 pi over 6. This is 7 pi over 6. This is 8 pi over 6. This is 9 pi over 6, 10 pi over 6, 11 pi over 6. And what you're going to get is some repeats. 10 pi over 6 is 5 pi over 3. This is thrilling. I know. 8 pi over 6, 9 pi over 6, which is 3 pi over 2. And then we can analyze this on this picture a little bit better now. So at 5 pi over 6, we're back to 3. So 5 pi over 6, that's why I spent all that time. There's that. Interesting. And then what happens from 2 pi over 3 to 5 pi over 6? These angle measures. Well, these angle measures, like for instance 3 pi over 4, we could go to the chart. 3 pi over 4 is 135. You get 2.2. So that's kind of why I'm piggybacking off the chart again. 3 pi over 2 comma 2.2. All right? So you get that. So, all these other angle measures, here's where 3 pi over 4 is somewhere in here. These are giving these positive radii value that start very small. The closer I am to 2 pi over 3, the closer it is to 0. And then they get bigger and bigger all the way up to 5 pi over 6, which gets the biggest. And then after 5 pi over 6, these y values start going back down all the way up to pi, which pi comma 0 happens. So everything between 5 pi over 6 up to pi, these radii values decrease. Put a little tick mark in there. So just pass. Oh, for the love of dog. This computer is driving me nuts. Oh, okay. Okay. Just past 5 pi over 6, we're very close to 3 for a radius. Whatever this value is, 10 pi, 11 pi over 12, if we put that on the chart, I bet you get a value somewhere, I don't know, between 3 and 1, something like that. And then all the way down, right when we get to pi for an angle measure, there's another pickup on the screen. You get 0. Oh, geez. Okay, my computer is going haywire today. Okay, now, what happens after this? I think what ends up happening after this is we start getting repeats. Like, what's after pi on the chart? 180. 210. 210, we get negative 3. And then I think we end up getting on top of each other here. 210 is 7 pi over 6. And I got negative 3 for that answer, which means... boom! I come across here. Oh, there we go. Now, the rest of this you're going to end up hitting all these other, this graph again. Like 7 pi over 6, you get negative 3. And then all these, which are all right here, flash to this. And then all these up to 4 pi over 3 flash over to do this, so on and so on and so forth. So there's your graph. You got it completed, and you have it completed once you start falling on top of what you've already graphed and completed. So that is a picture of a 3-petaled rose. Isn't it beautiful? Give it to your girlfriend or boyfriend or whatever you have, whatever. Anyway, so there's going to be some challenges on the homework. By the way, if you look at the homework, those are 3 of them. So you can kind of just emulate that through looking at this and then try to get the other ones. There's some doozies. Oh, yeah. I do expect some effort on there. I don't know what happened to that picture there, but computer's been crazy. So good luck and put some effort into it. You are in honors, and you can do it.